a stuff function. And again, I'll make the code available later on. I'm skipping ahead just a little bit. So here, that's the exact same query we use. We get our common name, our join, and then for our XML path is blank, and that's joined to the outer query, to sales order header, so that we get that one result per order ID. And it turns out beautiful and suitable for use in reports and email and all kinds of great stuff. And we will jump on ahead again. Wow, running through stuff fast. We're not going to get to everything, guys. That's okay. That's okay. There we go. All right. Accept and intersect. All right. This one also new in 05. Maybe I should do more stuff that's new in 08. No. It's forgotten T-SQL. You already forgot it. So again, I'm going to read from BOL because they really got it right. Accept and intersect returns distinct, and I'm emphasizing distinct, returns distinct values by comparing the result sets of two queries. So accept returns everything from the first query that doesn't exist in the second, and as you might guess, intersect returns distinct values from the rows that exist in both queries, the rows that match, in other words. This requires the same number and order of columns, and requires that the types be compatible, not identical, but compatible. So we're actually going to jump away from AdventureWorks here for a minute and use my own database called Speak, and I've got a setup file that'll well, set things up for you. So we've got two tables: a franchise quarterly table, which tracks quarterly information for franchises. It was well named, and then a franchise staging table that holds just 1 quarter's worth of data for when you need to import it. And I've done a select here, and you can see that for fiscal quarter, that's 2010, and then fiscal quarter 9, it's not actually the 9th quarter, clearly 9 is for September. Don't ask, it's something I'm used to. We can see that we have all of our franchise information in here, but assets and gross quarterly income and so forth are null. This is because in our particular process, see, I'm setting up a scenario here, we have let's try that again. For our particular process, what we do at the beginning of the quarter is load basically a blank template of franchises so that other data can be tracked throughout the month, and then at the end of the month we can update assets and so forth. So let's go ahead and compare using old school SQL, rocking it old school. What's new and old? What's in the left-hand table that's not on the right, and so forth. We see here these columns are what are they? They're the quarterly table. So we've got 2 new franchises right here, and then we've got 2 in the quarterly table that don't exist in the staging, and that means that those are closed down. So it's a nice little compare with a full outer join with nulls and all kinds of great stuff. Let's go ahead and demonstrate how we would do this kind of thing with intersect. So just to get the matching rows, we do our select ID and franchise name from franchise quarterly. And again, I should run this so that we're not ahead of ourselves. Select ID and franchise name from franchise quarterly, and intersect that with everything from franchise staging, and we get all the matching rows. These are all the franchises that existed before and still do. And moving ahead, if we want to get non-matching rows from the left table, from the quarterly table, those are just the closed franchises, then you would say select ID and franchise name from franchise quarterly, except everything in select. And I'm leaving out reading you the where clauses, but those are our closed ones. This is fairly simple, very simple process. And of course, if you want the new ones, then there's no way to get it to give you the rows from the right-hand table. So you just swap. You put franchise staging up at the top and fiscal quarterly down at the bottom. And there you go. And now you can see your new ones. All right. And there's a bonus compare with CTE down here that we're not going to go over. You can look at it later. That's what makes it a bonus. We're at 139. I think we've got time to jump into merge real quick, don't you? We'll make this our last thing. So using that same information, using those same tables, let's talk about merge. Merge is really cool. Merge is the fabled upsert that we've been waiting for years. We can go in and load our data from the staging table piecemeal. We can go in and say if exists update, and then another statement that says if not exists insert. But why would we want to do that? All the cool kids are using merge. All right, so we're going to go ahead and declare a summary of changes table so that we can see what happened after the fact. And then we're going to use our merge statement. Now, merge says I've got this source table here, so or this destination table. I'm merging into franchise quarterly. That's my destination, using this particular result set as the source. And here's my column list right here. So and I'm showing how it's joined together. So that doesn't really need explaining, does it? So here's our target, here's our source, and I've even named that source on QID and fiscal year and fiscal quarter. So what we say, we can do a couple of things. We can say when matched. We could also say when not matched by target or when not matched by source. So when matched, we perform this action. When not matched, we perform a completely different action. Very cool stuff. So when matched, update everything. And it already knows how they match because we told it so up here in our on clause, right? When not matched by target, then go ahead and insert those non-matched rows into our target table. And then we've got, just for funsies, our output action into summary of changes. And let's go ahead and run this because it looks cool. Yeah, there we go. I'm just selecting everything up to this point and running our merge statement. And the way we've got it set up, since we recorded our output into that little table summary of changes, we selected the change itself, the type of change, which was we have insert and update, and then the number of changes. So we had 2 inserts and 7 updates. But sticking with the merge itself, this is really cool because we were able in one fell swoop to go through and update where all of these were blank before, update those that already existed, and insert those that did not. We've got 2 columns here, 2 rows here that are still null because those are closed down. That's one of the, I will say, kind of a bummer things about merge is that you cannot do when not matched by target and a when not matched by source all in the same one. You can either do a not matched by target or a not matched by source, but not both in the same one. And that's a mild bummer, but that's okay. I can handle that. So that's kind of what we have, and I feel we've kind of rushed through that, but I do want to leave time for questions for everybody. So, Nancy, what have you got for me? I caught her unawares, unfortunately.
I just had to wait for my microphone to unmute.
Yeah, sure.
We have about 13 questions on here, so I'll go back to the beginning.
Okay.
The one that came through. I have one from Lane. If SQL resolves the on statement before the join, how does it resolve column aliases that are defined in the join?
Column aliases that are defined in the join. Let's go back and take a look at that then, and let's see if I understand the question properly. Let's see. Can you go ahead and read that for me one more time?
Sure. It's probably my inability to read it properly. If SQL resolves the on statement before the join, how does it resolve column aliases that are defined in the join?
I see. I'm going to have to say that's a really good question. To my understanding, the logical processing is more. My best guess would be that that's an exception to the column alias rule. But I don't think that, come to think of it, I don't think that we're talking about column aliases. This is not a column. We're talking about table aliases. So, my best guess is that it's sort of done at the same time. Yeah, I can't answer that one with any degree of accuracy. Let's Well, bonus points to anyone who gets me that answer. How about that?
Okay, I'll keep an eye out.
Yeah.
Okay, the next question is from Sylvia. What will be the performance difference between using CTE or create temp table and use subquery?
That's a great big, it depends. It really does depend what you're doing with one versus the other. There is no, now, did you say for recursive? Or just in general?
The difference between using CTE or create temp table and use subquery.
Okay, so for non-recursive operations, it's a great big, it depends. It's like saying what's better, a temp table or a subquery. Sometimes a subquery is better, sometimes a temp table is better. Sometimes a CTE is going to be better. It really is going to depend on exactly what you're doing at the time. And the best way, if you have, and you should make the effort, is to form those queries side by side and run them in a batch and compare them and see which one runs better.
Okay.
But for recursion, it's CTE is going to win almost every time, I think.
Okay, the next question. Earlier, it was mentioned that a semicolon was required where two CTEs are used. However, I didn't see a semicolon in the query used in the example.
No, I beg your pardon. Maybe I didn't make that entirely clear. It's not that a CTE with a statement with two CTEs requires a semicolon. That's not the case. When you have more than one CTE in a statement, they need to be comma separated. But all CTEs, so in a batch with more than one statement, require a semicolon before. So let's go ahead and take an example. And let's wait just a minute for this to catch up. Oh, I deleted my thing there. So I don't know if you can see this yet, but we've got our simple CTE with just one CTE defined, and then a statement before it. If you run those two together in the same batch, without a semicolon between, it will error out. So the actual requirement is a CTE requires that the previous statement end with a semicolon. There, that's nice and concise.
Okay. And I have from Jimmy, is CTE reusable or only for one statement?
Only for one statement. It's tied to the particular statement that you're using. If it's something that you're likely to need more than once, then you're looking at either you're looking at a view, potentially. CTE is a temporary view. A view is a permanent, globally accessible CTE.
Okay. CTE and T-SQL or just T-SQL?
Oh, excellent question. I'm not entirely sure. I believe I read that it's ANSI, but please don't quote me on that. I will check on that and put it in the blog with the notes.
Okay. Ready for the next one?
Yes, please.
Okay. Does the intersect and accept commands... Oh, sorry, I've just lost my... Sorry. Does the intersect and accept commands compare all columns or just the columns that make up the primary key?
Actually, neither is the case. The intersect, it's an excellent question. Thank you. The intersect and accept deals specifically with just the query you're looking at. Just like union and union all, it doesn't apply to the table. It applies to the queries that you're using within the intersect.
Okay, wow, we've got a lot of questions. Okay, next, are there performance benefits for intersect or accept versus outer joins?
I haven't necessarily run into that, but I'm not going to rule it out. I'll see if I can find a good resource on that too, where they've done some significant testing on big tables.
Okay, Jason asks, is the accept statement SQL 2005 and forward only, and is it more efficient than where not exists?
Oh, I would be willing to bet it's more efficient than where not exists, but I wouldn't. Again, I'd like to look that up. That's a good follow-up question to the last question. And yes, I believe it's 2005 forward only.
Okay. Garima asks if can merge be done on all columns without explicitly listing all the column names, something like